Okay. Thank you all for coming. Okay, so this is a sponsored talk from Renesas Electronics. I work for Renesas Electronics. My name is Mark Goodchild from the UK office of Renesas. This presentation, I'd like to just give a bit of background, who Renesas are, the sorts of things we're doing, introduce you to a few brands, Renesas brands. I don't want, but actually this talk's not about that. This talk's about how we built an open source tooling project, how we built on top of Eclipse and what we've done in that area. So that's what this talk is mostly about. Quick thing, who are Renesas? A lot of people don't even know who Renesas are. So we're one of the top semiconductor companies in the world. Japanese company, quite large, about 20,000 people worldwide, with development centers all over the world. So as I said, we're in the UK, there's offices in Germany, Japan, so on. But it's a Japanese semiconductor, that's the thing to bear in mind. And this is brand is Renesis Autonomy. So Renesis Autonomy is the term which we're using for this end-to-end platform for assisted and autonomous driving. And it encompasses everything that we do. So from the hardware, through to tools, through to software packages which we provide to the customer to give them a good basic building blocks for building their own autonomous systems. So this is Renesis Autonomy, and you'll see on our stand, but this is a big deal for Renesas. So one thing to consider, and one thing that Renesas has noticed, it is probably obvious, but maybe not everybody's thought about it, is we have these 5 levels of assisted and autonomous driving. From your most simple level, level 1, things like, and you can see here, things like automatic cruise control or brake assistance. And as we move through these levels, the complexity becomes exponentially big. So these level 1 and 2 applications, the sorts of applications we're already working on today, sort of smart camera. You see a lot of Renesas guys will be talking about smart cameras. This is just the beginning, and we understand that to move to full automation increases that complexity exponentially. Oops. Okay. I'd also like to introduce you to the Autonomy Platform. So this is what Renesas are providing to customers. So we have this idea of an open development, an open platform which people can contribute to. So at the lowest level, we have our Renesas original stuff, our lowest, our device drivers, software that sits very close to the hardware. And this is Renesas' bread and butter, has been for years. And this is what we do well. And then now we know that we see customers demanding much, much more from Renesas. So we have to have a bigger ecosystem, things around it, things to assist this growing application area. And then outside of that, then we're working with third parties and vendors and so on to build this autonomy platform. So why an open platform? Why is this important? Why is anybody bothered about this? So the software and tooling requirements for autonomous driving are hugely diverse and hugely complicated. And many companies either don't have the desire or the background technically to satisfy all those things. Renesas ourselves, there are specialist areas in this domain that we know we can't do on our own. So, and the costs and the resources and engineering resource alone that you'd need to implement an end-to-end autonomous driving project would be immense. So, consortiums, partnerships, and open source development communities is the answer to that, and that's what we believe. And this should reduce the cost to enter this market and make this much more accessible for everyone. So, for example, on Monday I was at the conference, and we're very interested in the simulation area at Renesas and getting hardware in the loop simulation. We're very interested in that. But there are so many, that's not a Renesas specialist area. We've no experience in that. But there are many people that do. So by coming to these open communities and having this discussion, we can leverage a lot of specialist knowledge we don't have. And it means companies that are making systems for autonomous driving, they can concentrate on the things that make the differential. They don't have to worry about this platform. They don't have to worry maybe about the simulation. Maybe they do, maybe they don't. But they can choose, and they can focus on the things that matter to them the most. So that's why we think collaboration open platforms for AD make a lot of sense for everyone, which is why we're trying to get involved. Introduce you to another term. So we already have this. RCAR is the brand of the device for this domain. So this is a Renesas device, an SoC. And already we're working in a very wide and diverse number of companies called the RCAR Consortium. And it's because of this approach of working with other people, specialist companies, that we have this. And we think there's a great synergy between this, which is not truly open, and then moving this and transitioning this into a fully open environment. We see a lot of collaboration with partners is hugely beneficial for us, because it means we can really accelerate our development. So we have this solutions vision, and for automated driving, we see there's a huge software stacks involved. You know, from the very towards at the bottom near the hardware, right up to this high-level software for automated driving. And Renesas at the moment are providing really just a platform. We're not necessarily providing that much, but we're expanding and diversifying that to provide more software, more building blocks that everybody will need. So we have this idea of we provide this scalable solution with cutting-edge vision technology that can cope with the demands of assisted driving. But then we also know that there's some customers that won't be interested in doing other areas of the software stack. And it's this area we think that open source can really help, because there's a lot of initiatives in the open source community, which we'll come on to later, that can reduce the barriers to enter this market. So why did we choose Eclipse as our tooling platform for this product? So we have a product called Renesis E² Studio. It's our Eclipse IDE, and we started doing this in 2011. Previously to that, we had a proprietary IDE, and that meant that Renesas had to take the burden of developing all of that sort of proprietary stuff that we take for granted in the Eclipse environment. So we could then just focus on what we do best, which is access to the debugger, specialist views, specifically for Renesas hardware. And until recently, this project focused on general purpose MCU, like our RX and RL78 device families. Not as widely known as ARM cores, but nevertheless, we supported those. So our requirements for the ADAS tooling. Why is this different? Why is this different from things that we've done before? The reason is we have three key use cases. One use case is high performance debugging of the RCAR SoCs. So this might be bare metal or real-time operating system, and we needed to provide specialist plugins for heterogeneous multicore debugging. So the RCAR device in itself is some ARM cores and a computer vision engine, which is like a 64-thread graphics processing. So this is hard to debug. This is going to be difficult for users to debug, difficult to work out what's going wrong when they hit issues. So we need a really good high-performance debugger with a lot of high-end debug features. Also, with the RCAR SoC, it's very another critical use case is Linux target debugging. We've got a lot of customers who, at least initially on some pre-development, are using Linux. So we need to be able to debug Linux applications. And then the third one, which is very, very important for our major customers, often customers choose an SoC that's some way away. It doesn't exist yet. So, and they want to get going with their software. They can't wait. They don't want to be dependent on our silicon. Absolutely fair enough. That's how it works. So we have the concept of a virtual platform, and that allows customers to develop their software on the PC. They can write all their algorithms on the PC and test them using a computer vision engine simulator. So this simulates the 64-thread computer vision IP. So that allows fast prototyping, fast time to market, all those things that they absolutely demand. So this is actually quite new. They actually press release that today for this IP. So we needed one tool that satisfies all those things. And you know where I'm going with this, because obviously the natural choice is Eclipse. You know, the product already existed. Our customers are familiar with it. It satisfies all those use cases that we really need. And it's an open tools platform. And for Renesas, that's very important. So we can capture all that ecosystem that's already there. We can work with partners, and they understand. More on that later. But they can understand. People can work with us easily, and that's a huge benefit. Yeah. So why did it make it easier? What, and what parts of what Eclipse projects did we use in making this product? So, like the Archive platform, we see Eclipse very much in the same way of providing building blocks that we can build our product with. And these are some of the things that we used. Eclipse offers a lot more than this, of course it does. There's many projects that are used, and are hugely wide and varied. But these were four of the main ones which we used as starting points for our project. So you can see there we've got the C, C++, CDT. We have Trace Compass, Nebula, and Eclipse TCF. So I'll go through each of those quickly in turn. So CDT. What is CDT? I expect most people know what CDT is, but C++ Development Toolkit. Our product is built on top of that. The CDT project's been running for more than 15 years, I think it is. And it's used for a huge number of commercial products, as is ours. We provide it free of charge, but it's still a commercial product. And it's very, very popular in the embedded IDE domain. I mean, it's almost to the point where it's almost standard to have it. And it has all the features you'd expect. So very strong project creation, very strong, a very strong editor, good source management, good project management. These are the key things that it provides, and we can just forget about all of that stuff. You know, it's there, and we work with the community to improve it sometimes and fix issues and so on with it. But ultimately, we don't have to spend a lot of resource to do this stuff. So that's a great start for us. You know, we get a lot for free, and we can really focus on the other areas that increase customer productivity. CDT also provides GDB integration. GDB is the debugger of choice that we use, and all of our debuggers are based on that. So it's a standard requirement, and we don't take it for granted, but it's a very strong debugger integration that CDT has with GDB. But it also allows us to access the heterogeneous multicore, which we need for this product. So we need to be able to debug not only the ARM cores on this SoC, but also the computer vision engine. They call it the IMP-X5. So this IMP-X5, complicated IP, that customers will definitely need to debug it. 64 threads, so it's a very, very capable device of processing camera output. And so we need this in one IDE, in one interface. The customer needs to be able to debug these processors and threads in parallel. You probably can't see that very well, but the left side picture shows the IMP-X5 simulator which we have, the virtual environment. So this is, and you can see, you could be able to see the cores and threads on this side in the debugger view. And then on the right-hand side, you can see the other use case where we're debugging the ARM and the IMPX5 actually on hardware. If you guys are interested, they're in our booth. We have demos of those things running. So, but this is the absolute critical use case for this, because when the customer is debugging and having a lot of trouble with why is the throughput not good enough, then they can use these tools to try and work it out. Another key part of the ADAS tooling is images and being able to view them in memory. So we needed an image viewer which supports multiple formats and so on. This is not maybe very novel, but we use the frameworks inside Eclipse and CDT to use the existing memory window to add an image, a raw image renderer. And it's just another way of looking at memory. That's the way to think of it. And we can also use our real-time memory facility, which was built into our standard E2 Studio, to then refresh this periodically, which is kind of useful on a camera input. You can see it refreshing and changing. So one of the key use cases is smart camera. This is what we're doing. So it stands to reason people need to be able to view those images easily within the IDE. One example of how it looks. Maybe nothing that novel, but it's integrated into the current memory rendering in the standard memory view. And you can choose memory formats which are specific for ADAS applications, a lot of monochrome formats and things like that. Trace compass. So trace, again, why is trace so important? You know, trace is important because if the customer is running with 64 threads and it goes wrong, you know, where did it go wrong? So a very, very high-end trace functionality was required by our lead customer. So with these complex designs, that was absolutely crucial and an absolutely mandatory requirement we couldn't get rid of. So we had to integrate Lauterbach. That was their key requirement. Mostly due, we have one actually down on the booth, the Lauterbach Power Trace, because of its huge trace throughput. So we use the CoreSight HSSTP trace functionality to suck down huge numbers of trace records. So yeah, so we support the latest and greatest Lauterbach JTAG probes. So HSSTP trace can really output huge numbers of trace data. And traditionally, when we were making our proprietary IDE, that was always an incredibly difficult thing to deal with. The trace window is one of the hardest views to write from scratch. So, but we had this bright idea. We were thinking, well, hold on a second. There's a trace compass project. It's designed to work with Linux traces. It can handle huge amounts of trace data already. So, so we decided, well, let's see if we can harness the Trace Compass project inside E2 Studio and hopefully cut some corners and make a much better end job than doing it ourselves. So, right, so yeah, so Trace Compass already provides Linux trace, already mentioned that, but they do have an extensible framework which we decided to try and use. And as standard, and there's some standard views that you can get. There's a statistics view. I think there's some kind of history view. There's and you can get a basic raw trace view, which has really great filtering and search capabilities. But the thing that it is more than anything is absolutely lightning fast. It's very impressive. I'll show you an example of a couple of mock-ups. Well, not mock-ups. This is some screenshots of our product. So what we managed to do is we built up this call flow view, which gives you a kind of sequence of events and tying it back to the actual source level that you can see. It's very blurry, but this here is the actual raw trace. So you can see on the top there's filters and things like that. So you can say, well, if I'm only interested in a certain area or something like that. So it's a very, very powerful UI, which actually we could build up very, very quickly, relatively quickly. We also have this concept of DTA trace, which is debug trace agent. So this again uses the same sort of core site trace functionality, and it uses the same path using the Lauterbach JTAG probe, and it receives various events about what's happening with the cores when they're woken up, when they go to sleep, when they're interacting with each other. Again, this is an absolutely critical requirement for end users to try and debug their systems. So again, this is another view built on Trace Compass, and this is the view. This is the view here. You can see. So these are two CV engine cores communicating with each other, and so on. And you can highlight at any point and see what the situation is and what the status of those cores was. Right. So Nebula. Nebula is actually a relatively recent thing that we've started to use. So visualization of data in a debugger is absolutely critical. You just giving someone a load of raw data and in a view in a table generally doesn't really satisfy anybody. And sometimes it can hinder more than it helps. So what we're trying to do is change our views so that we can show charts or graphs or show things visually, so it's much more obvious to the user what's going wrong. And this is made easier with Nebula. So Nebula has functionality explicitly for charting and showing visual data sets. Some libraries and plugins. So in the E-Squared Studio ADAS project, we've used that in our bus monitoring plugin. So the bus monitoring plugin is again, as you can imagine on the SoC, there's many IPs connected with various buses. Again, if the customer has some issues with performance, how do they know what's causing that performance? So one of the things they can do is they can monitor the bus throughput for each of these buses, and this can then be charted. So if you've got some issues, maybe camera's not being processed quickly enough, and you've got some stutter or some breakup in your images or something, or you're losing images, something like that. This would be one of the places to start to debug your system. So using Nebula to do this kind of charting can show very easily and very visually what might be wrong, and making the debugger much easier to use. So this is a picture of the bus model. It's a very simple picture. You can also see there's an awful lot of buses there that could potentially be charted, but it could be very obvious if you see a picture like that which area is causing you issues. Finally, from the things that we've used, so Linux target debugging, as I said, is a crucial requirement. Actually, it's even more important than we thought it was going to be. So when we press released our latest device, most of the interest was focusing on AGL, really, or automotive grade Linux. So this is supported by CDT and the Linux tool project, obviously, and it pretty much works out of the box. We did use the TCF, the Target Communication Framework, so that we could communicate with the hardware over Ethernet. But essentially, it just works, and we just took it, and we could get up and going with this really, really quickly. So I also like to quickly talk about partnerships, because when you're in an open community like we are, it makes it much easier to work with other people. So using the Eclipse framework, it's so much easier to collaborate than it was before. Normally, when we were doing our proprietary IDE, partners would just shut down. You say, well, we're doing our own thing, and they're just not willing to invest in anything that's not open and can be shared. You know, because it's a waste of their investment. They can only use it once. Whereas in this case, the investment is shared, and you can use it again and again and again. So the Eclipse platform is open, and the interface is well known. So it also means that we could pick up plugins from other companies without any effort at all. And other partners because they understand, for example, Eclipse and GDB and so on, it's much easier for them to collaborate with us. We're talking the same language all the time. So pick out 3 examples that were actually done for the ADAS E2 Studio product. The first one is Lauterbach and their Trace32 debugger integration. So Lauterbach provided some software to us which we integrated relatively easily with our E2 Studio environment. The other one was ASTC. So they're a company that specialize in virtual environments, and they actually developed the CV Engine IMPX5 simulator. So they're a company based in Australia, and actually we didn't really need to do that much. They actually implemented the GDB server side, so the whole debugger back end they just implemented. We didn't really have, so there was a little bit of discussion about launching it and integrating it E2 Studio a little bit, but ultimately to get such a crucial feature as that, we didn't really need to engage with them that much. And then finally, our friends at ARM. Our customer wanted to use the ARM compiler, the ARM version 6.6 compiler, and very kindly, the guys at ARM have allowed us to use the plugin straight out of DS5. So we just couldn't have done that if the environment was proprietary. It would have been impossible. And the ARM DS5 environment is based on Eclipse as well, so we could just take it and everyone's happy. Future plans, very grand. So for us, traditionally, we're a semiconductor vendor. Allowing people to debug and use our IP is traditionally what we're interested in, and it's been our focus, which is natural, I think. So we're still going to provide that specialist debugging capabilities for our IP and our application areas at which we're working. So that there's no issue with any of that. But the thing is we're very, very aware that customers are going to expect much more from us, much more, and we need to come further up the tool chain. So we can't be just down here by the hardware. We've got to provide more software building blocks and more things which customers can use to access this market more quickly. So we know that we're going to have to do pre-development tools. We know that's already happening. We know that we're going to have to get involved in simulation. We know that we're going to have to get involved in hardware in the loop simulation. We know that it's going to happen because automotive companies don't want to spend their whole time on the road. We know that. It's too expensive and too difficult. We also know that from a data analysis point of view, if our device is firing out all of this data from various sensors in the car, and they'll want data from the SoC itself, these huge data sets are going to be created. We know that they need to be analysed. We know that they need to be visualised. We know this is something, again, that we're going to have to get involved in. So we know that all these things are going to be required for efficient AD development. So with that in mind, we are very, very motivated. Already, we were at the Automotive Unconference on Monday to get involved in some of these working groups. In particular, OpenADX and App4MC are the 2 main ones which we're currently engaged with. I don't know how familiar you guys are with these things, but OpenPass is a sort of traffic and environment simulation for scenario analysis. Sumo's traffic and urban traffic simulation. OpenMDM is to do with the large data sets I was talking to you about. And OpenADX is the moving towards connected tool chains. So we can integrate tools more easily. Okay. So going back to this picture, we know that this is the current picture, the ecosystem, but we are fully aware that ecosystem now, it needs to be more open than it currently is, and Renesas are committed to move this development up and contribute much higher in the tool chain than we do currently. Oops, do that again. So final thing, won't bore you much longer. So we really do appreciate the open communities, and we understand the value, and we're motivated to join these groups, in particular, as I said, Open ADX and App4MC, and because some contribution really underlines the value we know we can get from this, because there's so much specialist engineering resource in these groups that we just don't have. So so that's our motivation, is to help where we can help and where our specialist area is, and then gain where we don't. So so yes, we're there for the open ADAS open source tooling. Any questions?
What are you considering for, which plugins are you considering for code coverage, certification, user checking, and so on?
We have some of those already, some in-house, some not. It's something we're continually looking at. I probably don't have an answer to those yet. For our proprietary tools, we have coverage plugins already. I think we used an open source one and modified it, I think. But for this, not yet decided.
Are there any plans for dependency management for C++ libraries or C libraries that are used for autonomous driving?
Not yet. I don't think we've got any plans, William, have we? Not yet. Is that something you think is? Okay. Yeah. Okay. Any other questions? Thank you very much.